Very good evening, everyone. Welcome to this webinar. We'll wait for another 2 or 3 minutes for others to join, and then we'll kickstart this webinar. Meanwhile, if you've got any questions or anything that you'd want to understand regarding the previous webinars or even today's topic, you can drop in the messages. We'll wait for others to join. Meanwhile, let me take the confirmation. Hope my screen is visible to everyone. Can somebody confirm?
We can see you.
Wonderful. Thank you, Ravi. One more minute to go. It's 4:32. We'll start at 4:33. All right, it seems it's 4:33. Let's kickstart the discussion. Welcome everyone to the 12th session of the Navigating Net Zero. The topic today is manufacturing emissions uncovered. We're going to talk about one manufacturing industry. We'll prepare a GHG inventory for that particular industry or project, and then we'll see how what are the various challenges, how we can look at decarbonization and many things. We've been doing this in previous webinars, also looking at sector-specific projects and decoding how we can talk about net zero there. For everybody who is joining for the first time, we've got about 11 more webinars. This is the 12th session. We've done several webinars on carbon counting, scope 1, 2, and 3 emissions, even BRSR, which is sustainability reporting for India, various other webinars related to ESG regulations, and finally, webinars related to scope 3 emissions, particularly the last one where we spoke about the construction industry. Now, today we are going to talk about the manufacturing industry. While this webinar is a short one, let's try to make it an interactive session. Participants can raise their virtual hands and they can ask questions. They can also post their questions in the chat box. Okay, so please feel free to do so. My team members are also there with me. They'll inform me in case there are questions that I'm not able to see because I'm presenting my screen right now. Let's move ahead. This is how the flow of the webinar would be. We'll talk about the case study. We'll prepare a GHG inventory of the manufacturing company. We'll talk about net zero and decarbonization, and ultimately we'll summarize this. Right. This is a very, very brief topic coverage for today's webinar. Let's talk about the case study. This is a steel manufacturing company in India. This is a very big company manufacturing steel, specifically in the uh, the central portion of India, central India. Now it has got several plants. However, what we are doing is we are covering only one plant. The capacity of this plant is about 375,000 tons per annum production capacity with respect to steel production. The operational boundary, which we are going to, of course, cover is all scopes, which is scope 1, 2, and 3. Now, you will see with respect to the previous webinars and this webinar that the scopes emissions are different. The categories are, of course, different. And of course, the breakup of emissions also, you will see that there is a huge difference, when we talk about real estate to this sector, and you will see similar trends in other sectors in the coming webinars also. So the reason that we are covering it, all the different sectors is so that people understand what are the different scopes, how they differ, how the decarbonization strategy has to differ in terms of its action. Now, here in this case, this particular plant talks about manufacturing of steel with the process which is DRI, commonly known as, which is direct reduced iron. Now, the fuel used here is coal, which is fed into the rotary kiln, which is coupled with an induction furnace. So that is the setup over here for the production of steel. Additionally, rolling mill is used to roll the steel which is produced for storage and transportation. So that's a very brief about the project. Of course, this is a very large plant, and you will see the scale of production over here. So 375 tons of steel production per annum is a huge quantity, in fact. So what is there in scope? Today, we are going to talk about all the activities in terms of the production of the steel. And we are going to map these activities with respect to the respective scope 1, 2, 3 emissions. Finally, what we are going to do is we are going to prepare the GHG inventory of the plant for this one specific plant. Of course, there are about 6 or 7 other plants that we are not talking about. This is the plant where this is actually a live project where we are receiving the data on the go. In fact, right now we are engaged with them. And what is happening is we are trying to understand what is happening at this particular plant. This is a pilot project, and this will ultimately be taken up for the entire company. So this is a very good case study for us to focus on. Now, operational and organizational boundary, we have already covered in several sessions, in the several webinars. We'll briefly talk about that. I have already spoken about the organizational boundary. While there are about 7 or 8 plants, we are going to talk about only one today. So organizational boundary is defined. Operational boundary is when we talk about the different scopes. So upstream activities, downstream activities, as well as which is part of the indirect emissions, as well as the direct emission, which is scope 1. Now, here in this case, of course, the same things repeat. We'll talk about the various activities, which is purchase of raw materials for the production of steel, the usage of steel, usage of electricity for the production of steel through the induction furnace, the transportation of material to and away from the plant, which is primarily the iron ore, coal, and many other elements which is coming in, and finally the production of steel, and then taking it to other plants or other businesses for further processing. The usage of fuel and the use of equipment, among many others. These are the top ones for the plant. Quickly, we'll talk about the calculations. We have done this earlier as well. Now, there are 2 components to calculation of emissions. One is the activity data itself and the emission factor. Finally, calculating the total emissions for that particular activity. Now, activity data, of course, are different. So it could be in the form of electricity consumption, which can be in the form of the units of electricity, that is kilowatt hour. It could be fuel consumption, can be either volume, weight, or energy. So whatever input is there, material consumption, transportation, or waste generation. So activity data, these are some of the examples of the activity data. Thereafter, the important portion, which is at the emission factor. Now, emission factors can be local or global. So we'll definitely talk about the emission factor databases that we've used in this particular study. Now, as against each of those, the emission factors will talk about the activity and how it is to be converted into tons of CO2 equivalent. So, for example, in case of electricity, we'll talk about what is the total carbon dioxide emitted per unit of electricity being used. We'll take an example of India for an example. If you've got this much amount of electricity being utilized, at 3.4 million in this case, we multiply it with the emission factor, which is 0.713 tons of CO2 equivalent per megawatt hour. This is one data that is available at Central Electricity Authority of India. Finally, you'll get the total emissions for the activity, which is now, if we convert all of this into relevant units, because my emission factor is in per megawatt hour, I'll convert the kilowatt hour into megawatt hour. So 3,400 megawatt hour into 0.713 tons of CO2 per megawatt hour. That gives me around 2,424 tons of CO2 equivalent. Now, the same trend will repeat throughout the presentation. We will not talk about unit conversions a lot. We'll focus our energy in understanding the right activity, understanding the emission factors. The final calculation, of course, you can do it yourself to a certain extent. That unit conversion is not covered as part of the breakdown of the emissions or calculations, right? Let's dive into the GHG inventory of the manufacturing activity. Uh, Now, we'll first focus on the scope 1 and 2 emissions. Then we'll try to focus on the scope 3 emissions. Now, in case of scope 1 and 2 emissions, these are the various categories available. So for the sake of everyone, these are stationary combustion, mobile sources, leakages due to refrigeration and air conditioning, leakages due to fire suppression, and if there are any purchased gases which are being utilized uh, within the process itself. In case of scope 2, these are purchased electricity and steam. Very specific to the steel production sector, steam is more uh, byproduct. It is not used for the production of the steel. It is more a byproduct. Many steel production companies also are called cogeneration, and in fact, steel comes out of it as well. So, but that is not the case over here. We are not considering that as part of the operational boundary. Let's talk about scope 1 emissions. We'll look at the various calculations that there are. So we'll first talk about stationary combustion, mobile sources first. Here in this case, let me remind everyone that refrigeration and air conditioning and fire suppressions are the data isn't available or it is very minuscule, which is why it has been eliminated here. However, there is definitely a possibility that there is a large refrigeration and air conditioning plant. In that case, it has to be considered. However, we'll focus our energy on stationary combustion and mobile sources, which in case of steel production are the highest emissions as part of the scope 1 emissions. Now we'll first talk about the stationary combustion, which is the utilization of coal over here. So you can see 339,000 tons of coal is being utilized annually for the production of steel. Here the emission factor is 2.35 kilogram CO2 per ton of coal. Now, this is the emission factor used as part of the US EPA. There is a very specific reason that we are talking about US EPA. Many of the emission factors may or may not be publicly available, whereas US EPA is something that you can find directly. So it becomes easy for you to cross-reference and see how the calculations are done. Now, again, here, the emissions are in kilograms CO2. The final emissions that we have represented is in tons of CO2. So coal is one of the key components that goes under the steel manufacturing and which is considered over here. The other thing is in case of scope 1 emissions, the diesel consumption. Now the diesel consumption can be for multiple purposes. It can be used in the vehicles for transportation of material. It can be used for the electricity generation for on-site diesel gensets. Now here, we have utilized about 285,000 liters of diesel annually for this plant. The emission factor is about 2.7064. The total emission is 771 tons of CO2 equivalent. Next is LPG. LPG has been utilized in this particular plant in terms of the quantity. Quantity is very less, about 17,800 tons of LPG has been utilized over here. The emission factor utilized is 0.003 tons of CO2 equivalent per ton of LPG. So that has been utilized over here. So total emissions is about 53. Now here in this case, the source which has been utilized is UK DEFRA because the same was not available for US EPA. Moving on, we'll talk about process emissions. Apart from the fuel that has been utilized for combustion, you saw coal, diesel, LPG. There's of course process emission over here. Now the process emission is something that is part of the entire process or the reduction process of uh, the iron ore. So iron ore is an oxide of iron which is broken down into iron and other components. That is how the steel is manufactured. Now here in this case, dolomite is used as a reduction agent, and the emissions are directly related to the dolomite consumption. So in this case, dolomite, 15,300 tons of dolomite was utilized. Emission factor is about 0.477 tons of CO2 equivalent. Now this emission factor is available from IPCC 2006. So these were the scope 1 emissions for the steel production. Now we'll go on to scope 2 emissions. Again, steam is not considered over here. We are talking about purchased electricity. In case of purchased electricity, there are three types of electricity being utilized over here. So we have broken it down. The first one is the utilization of electricity for the furnace itself. So the induction furnace, which heats up the iron ore and helps in the reduction process itself. So you can see about 2316, so about 2,316 million uh, uh, units of electricity has been utilized for the induction furnace. The emission factor utilized here is 0.713, which is considering the renewable energy component, which is available at India CEA. Now, when I say considering the renewable energy, the India CEA talks about two emission factors. One is considering the renewable energy factor, that is about 20 to 25% of renewable energy, which is part of the grid of the part of the Indian grid rather. And the other emission factor where the renewable energy is not considered. So because we are utilizing the common grid, it is always preferred to consider the emission factor with utilizing the renewable energy. So 0.713 is what has been used over here. This is CO2 equivalent per megawatt hour. So of course, you need to convert the kilowatt hour into megawatt hour and then multiply it. So you can see over here that is 1.6, so around 165 tons of 1,000 tons of CO2 equivalent has been produced as part of the utilization of electricity in the induction furnace. The second type of electricity being utilized is for the DRI process itself, powering the other mechanical instruments around the induction furnace. For that, about 20.4 million tons, a million kilowatt hour of electricity is being utilized. The equivalent emission is around 14,545. Similarly, for the rolling process, wherein the steel being manufactured is rolled into sheets, for that purpose, about 42.8 million units of electricity is utilized. The equivalent emissions for that is 30,516. For all three, the emission factor being utilized is 0.713. Moving on to scope 3 emissions. In case of scope 3 emissions, you can see clearly what are the scopes which are applicable for steel productions and what are not. Now, some things are very simple. Of course, we'll talk about each and every of them, every scopes in this case. Now, some things are very simple. for an example, the upstream leased asset and downstream leased asset, which are not there as part of the steel production. Franchisees and investment are also not part of the steel production. Use of sole product is something that is not considered. While there is a possibility of calculating the emissions due to use of sole products, this is something that is not advisable. Rather, in case of product usage, in case of steel production, we mostly talk about processing of sole products, which may happen down the line. For an example, in case the steel goes to another company for processing and ultimately into a finished product. So that is what is being considered, which is processing of sole products. And finally, end of life treatment of sole products, which is where recycling or any other treatment might come into place. So all of these categories, we will break it down. We'll talk about all of them in bunches where there are similar categories. The biggest category in steel is, in case of scope 3 emissions, is the purchase goods and services and capital goods. For purchase goods and services, the first component is the iron ore mining. Now, the iron ore required over here was about 542,500 tons. The emission factor utilized over here is 0.08 tons of CO2 per ton of the iron ore utilized. The total emissions is about 43,400 tons of CO2 equivalent. The emission factor here being utilized is sourced from World Steel, which is one of the renowned organization for performance as well as standardization of steel manufacturing across the world. The second one is coal mining. For coal mining, this is the amount of coal which was utilized throughout the production annually. So around 339,075 tons of coal was utilized. The emission factor over here is 0.05 tons of CO2 per ton of coal, which is being utilized in the process. The source here is IPCC. The emissions totaling is around 16,954 tons of CO2 equivalent. Next is dolomite mining. The dolomite is a reducing agent in the steel production. Now, around 15,300 tons of dolomite was utilized. The emission factor is 0.03 tons of CO2 per ton of dolomite utilized. The total emission is around 459 tons of CO2 equivalent. Again, here the source is World Steel. Finally, in the entire process, alloys were utilized. The alloys are multiple alloys were being utilized for this. Around 3,200 tons of alloys were utilized. The emission factor is around 0.213 tons of CO2. Again, the source is World Steel. Now, these are all based on the standard processes that are being utilized in production of the steel. These are the major components that go into the production. Lastly, we've got scrap. In case scrap metal comes in and that is being utilized or fed into the kiln itself, that is also considered under scope 3, under the purchase goods and services. The scrap utilized here is around 36,300 tons. Emission factor here is 0.05 tons of CO2 equivalent per ton of scrap being utilized. The total emission is around 1,815 tons of CO2 equivalent. Again, here the source being utilized is World Steel. Now, during the reporting period, there were no capital goods which were utilized, which is why there are none reported in this particular year. These were all related to purchase goods and services. Moving on, we'll talk about transportation categories. So these are the major categories which involve some or the other use of transportation, which is upstream and downstream transportation, employee commuting, and business travel. Now, in case of upstream transportation and distribution, of course, there is the raw material which was transported to the plant site. Now, the Breakdown you will see is with respect to all the modes of transportation that was taken up. For an example, rail, road, and sea. In each cases, there were multiple modes of transport. For an example, in case of iron ore, of course, rail was utilized as well as road was utilized. What we have done is we have calculated the total ton kilometer of transportation of the iron ore. This is from the source till the plant. So from gate to gate. So in case of iron ore, there were two modes, which is rail and road. So these are the equivalent ton kilometers that were calculated for each of these modes of transport. So you can see around 1,627,540 tons kilometer for rail, whereas about 2.7 million tons kilometer for road. So these are the equivalent uh, distances for each of them. The emission factors are sourced from the India GHG program, and that is being utilized over here. The equivalent emissions is 1,546 for rail and about 20,000 for road. Because road, in case of road, number one, the emission factor is huge. Second is the distance traveled is more. So the breakdown in terms of rail and road, the road has a huge component over here. Let's talk about coal then. Again, in case of coal, there are two components for rail and another for road. In case of rail, of course, we've considered from the source till the from gate to gate. In fact, so whatever distance has been considered, this is again ton kilometer that has been calculated for rail as well as road. The emission factor used here is 0.0095, which is same as the one for iron ore. Now, I'll not repeat all of these again. I think the emission factors are very clear for road as well. So total emission is about 12,500 tons of CO2 equivalent. Then there is the utilization of dolomite, the reducing agent here. For in case of dolomite, it is only road transport that has been utilized. That is around 765,000 kilometers. The emission factor here is 0.7375. Again, sourced from the India GHG program. For alloys, the total distance traveled over here is 9.6 million for C, and another 320,000 kilometers by road. Now the emission factor here are the same that has been utilized. For scrap, it is around 3.6 million kilometers, and the emission factor is used for the road. So these are the various categories for the upstream transportation. Talking about downstream transportation and distribution, now again here in this case, the finished product is transported to different locations, particularly for processing again into finished products. Now here there are three modes of transportation, which is again rail, road, and sea. And the equivalent distance over here, which is considered average as around 300 kilometers. The same has been calculated. So the equivalent kilometers has been calculated for all of them, and the respective emission factors are utilized. So the total emission here in this case for rail is 1,015 tons of CO2. For road is around 78,000. For sea is about 855 tons of CO2. You can see the sea transport is very much efficient and as compared to rail and road. Now, in case of employee commuting, uh, again, there are different modes of transportation. Here in this case, most of them are on-road vehicles. There are three modes of transportation used by the employees. Because most of the employees are living not very far, the emissions related to employee commuting is not much. So you can see about 0.2 with respect to the transportation by car, about 0.03 with respect to the bus, and about 0.68 with respect to bike. So these are the breakups with respect to employee computing. You can clearly see that we have considered about 1740 kilometers for car transport, around 2,375 kilometers for bike transport. And in case of bus transport, we have considered about 2,064 passenger kilometer. Now, passenger kilometer is different than the transportation of the vehicle. So here in this case, an individual person traveling for a particular distance is considered as a passenger kilometer and not the entire vehicle. The emission factor used here is sourced from the India GHG program, and these are very specific to India. Finally, business travel is about 1,740 with respect to car that has been utilized in this particular case, which was reported. Moving on, there is no report with respect to upstream and downstream leased assets. Ideally, in case of steel manufacturing, these would not apply. Thereafter, we've got waste generation and operation. In case of waste generation and operation, we've got multiple waste which are generated as part of uh, the steel production. First one is slag. About 42,750 tons of slag was produced. The respective emission is about 240 tons of CO2. Around 1,068 tons of dust was produced. Equivalent emission is about 2 tons of CO2 equivalent. Oil and water are also part of the end product, or rather byproducts over here. The total oil and water consumed was about 178 tons. The total emission is about 9 tons of CO2 equivalent. Let's move on to the next category, which is fuel and energy related activities. Now, as we all know, and we have discussed in the previous webinars also, that whatever fuel we are utilizing, there are emissions related to other than combustion. For an example, if you're utilizing diesel, the diesel is sourced from some place and then bought it to the location for utilization. Now, this particular emission is called well to tank, and that is considered for all the fuel consumption. In case of electricity, it is the transportation and distribution losses that needs to be considered. These are emissions which are not considered as part of scope 1 or scope 2 emissions, and that is why these are considered under scope 3 fuel and energy related activities. So let's talk about purchase electricity. So the emission factor used here is 0.01811. Now, so the total electricity being utilized over here is around 2,948 million units of electricity. And for the same, the total emissions, which is other than the purchase electricity, is around 55,454. Similarly, coal is being utilized. So the same amount of coal is considered over here. The emission factor is about 497 kilograms CO2 equivalent. The total emission is about 168,520,000. The trend is similar here in this case for LPG. About 17,800 kilogram of LPG was utilized. Equivalent emission is about 6 tons of CO2 equivalent. All of these emission factors are sourced from UK DEFRA, which is a very well-known emission factor database. Finally, we are on to the last two categories, which is processing of sole product and end of life treatment of sole products. Now, here in this case, what is happening is we are utilizing emission factor sourced from World Steel, which kind of summarizes the utilization or rather processing of sole product waste emission into a single unit, uh, considering the entire value chain of steel production. The emission factor utilized here is 0.02 tons per ton of steel production. The total emission is about 7,125. Thereafter, we are talking about end of life treatment of sole products. Here in this case, the emission factor utilizes 0.005 tons per ton of steel production. So total emission is about 1,781. Again, the emission factor being utilized is sourced from World Steel. Finally, this is the summary of emissions under the different scope 1, 2, and 3 categories. So these are the 5 categories of scope 1 emissions. The total emission is about 716,480. In case of scope 2 emissions, it is 210,192. And finally, in case of scope 3 emissions, the total emissions is about 430,741. So you can see, contrary to previous webinar wherein scope 3 emissions was about 75 to 80%, here in this case, scope 1 emission is the largest emission, right? Uh, you can clearly see this over here. Now, when we talk about the overall breakup, scope 3 is about 53%, uh, followed by scope 1 is 53%, followed by scope 3, which is 32%, followed by scope 2, which is about 15%. So electricity is the lowest amount of emission producer. Uh, the the scope 3, which you can see the breakup on the right hand side, considers primarily emissions due to you can see clearly fuel and energy related activities, which is about 52% in case of scope 3. Uh, Thereafter, you can see about 18 and 19%. These are categories related to purchase goods and services uh, and transportation related emissions. So 19% is transportation related emissions and about 18 is purchase goods and services. Rest 52% is of course, related to fuel and energy related activities. So this is an interesting fact about the steel production. The fuels itself take a major portion of emission, are part of the major portion of the emissions. So naturally, when we talk about decarbonization, it will be primarily focused on either reducing in terms of the fuel usage or fuel switching. Of course, we will see it shortly. Before I proceed, a quick time check. What is the time remaining with me? Ravi or anybody can confirm.
8 minutes left, Himanshu.
Okay, great. Thank you. Wonderful. So let's talk about the net zero roadmap. And when we talk about net zero roadmap, we have to talk about the decarbonization plan, of course. Now, the assumption here is that we are planning for a net zero by 2050. These are the various activities that can be planned as part of the decarbonization roadmap. So what we have done is we have broken down all the activities that we can do as part of the decarbonization roadmap into 3 goals, which is short-term goals, medium-term goals, and long-term goals. Short-term is considering till 2030, medium-term is till 2040, and long-term is till 2050. 2050 is the ideal case when we'd want to achieve the net zero status. Of course, in case of India, the India, in case of India, we have considered 2070 as the net zero year. So it is up to the companies to adopt either 2070 or 2050. This is considering the best case scenario. Now, for the short-term goals, what can be done is the first thing that comes to mind in case of steel manufacturing is the energy efficiency, particularly talking about waste heat recovery from the DRI kiln. DRI, of course, is direct reduction of iron. Talking about energy efficient motors and applying variable frequency dives wherever applicable, and digitizing the monitoring with respect to the temperatures, with respect to the movement of materials. All of that is possible through IoT and AI, and this will ultimately lead in reduction in fuel consumption. So, or rather, more towards fuel optimization. So energy efficiency plays a major role in terms of the fuel consumption and in enhancing the performance of the project. The second thing is the fuel and feedstock switch. Now, while this particular project talks about coal being utilized for the production of steel, natural gas is something that can be moved on towards. Now, when we use natural gas, the emission is lower as compared to coal. Again, considering that natural gas switching is possible in case of DRI cleans. Now, this is again based on if the pipeline access is possible at the plant location. Second is increasing the use of scrap. Now, again, here the scrap usage you saw was less than 10%. If we increase it to 20 to 25%, the relative emission will reduce. Primarily, what will happen is our reliance on mining will be very less, and that is something that we'd want to achieve. If we move away from mining, or rather, in fact, 100% is not possible. Some amount of mining will certainly happen. However, if we rely more on scrap and reutilization of the scrap, then the total emissions will reduce significantly. Third one is renewable electricity. Of course, this is known to everyone. In case of steel production, a large-scale solar plant is not possible because, as you can see, the demand is very huge. In such a case, power purchase agreements are preferred either for solar or wind, at least offsetting about 25% of the power requirement. This is something that can be planned by 2030. Finally, in terms of material efficiency, improving the yield to reduce raw material usage. Of course, this is very slow or very minuscule increment. Even 1 to 2% is quite huge. However, that is something that can be planned in short term. So these are the various activities that can be planned as part of the decarbonization roadmap for the steel manufacturing plant. We'll quickly talk about the midterm goals, which is by 2040. Now, while we said we'll talk about natural gas, there is also a possibility of utilization of hydrogen-based DRI plants that can be explored. Hybrid operations, wherein we've got about 30 to 40% of green hydrogen being blended into the operations, or for producing the heat, for reducing the iron. Second is circular economy. Now, it is very much possible to shift to an electric arc furnace. Now, in that case, we can increase the percentage of scrap metal being utilized because it is very easy with respect to electric arc furnace charge. Second is partnerships for end of life steel recycling, which is happening to a certain extent in India. However, if the steel recycling is the life cycle is managed really well, then the scrap percentage will increase significantly, thereby reducing the mining requirement. The next thing that can be done is carbon capture, utilization, and storage. Of course, during this point of time, what we are suggesting is this can be a pilot. Here, in this case, we can capture the CO2 which is being produced, and we can store it, and ultimately this becomes a pilot for the project. Now, up to about 10 to 15% of CO2 can be captured and stored through various methods, and these CCUS is something that is upcoming, and a lot of innovation has happened in this particular area. Second is explore mineralization of slag with captured CO2. This is again that is possible. So if the slag which is coming out of the steel plant, if that captures the CO2, then that is also part of the carbon capture pilot that can be explored. Next is green power. Now we said that about 25 to 30% of green power can be utilized. We can move on to 50 to 60% based on the availability. And if some of them can be offset using battery storage, that is preferable. Finally, possibility of usage of green hydrogen via electrolysis. This is linked to renewable energy that can be explored. Let's talk about the long-term goals. By 2050, we can shift entirely to 100% hydrogen-based DRI, which is direct reduced iron. full electrification for whatever electricity requirement is there, which is 100% renewable electricity. Of course, we've said this earlier that it is not possible to have on-site solar. These are all possible through power purchase agreements of off-site solar and wind. Carbon capture at scale, of course, increasing the scale of carbon capture. In this case, circularity being maxed, scrap content of more than 60% wherever possible. Of course, there is when the percentage of scrap increases in the steel production, what happens eventually, the amount of scrap available in the market reduces, and then again, you go to mining. So these are all conditional, but maximization of circularity is what should be targeted. Finally, green logistics, which is utilization of EVs or hydrogen trucks for the transportation of raw material as well as transportation of finished goods. So this is the overall decarbonization roadmap for a steel manufacturing plant. We have seen the GHG inventory, and if you plan really well, then achieving net zero is definitely possible for a large steel plant as well. If there are any questions, I can take them up. Otherwise, we can move ahead. Ravi and others, if there are any questions that are posted, please do let me know. All right, if there are none, let's move on. So while we have prepared all of this greenhouse gas inventory and we've spoken about the decarbonization plan as well, now all of this is not possible on an Excel sheet. While we have presented it really well, it is usually preferable to use some or the other tool for calculation of these emissions, tracking it over years, and ultimately preparing a decarbonization plan and tracking your targets, which is where Sustainium comes in. Now, Sustainium is a platform, a SaaS-based platform that can be utilized for the same. We've got multiple benefits of utilizing Sustainium for this particular process. Now, here in this case, you can automatically track the data collection for scope 1, 2, and 3 for all the sites, as well as in case of scope 3 for all the suppliers and contractors. Now, this is not possible through an Excel sheet or spreadsheet. So this solves a lot of problems for data collection. Second is, once you've collected all of this data, it is very easy to produce custom reports and prepare yourself for disclosures. You can directly prepare a GHG report in line with GHG protocol. For the Middle East, we can directly prepare the GHG inventory with respect to the UAE climate law. And of course, we can prepare several reports for compliance for BRSR, ISSB, CSRD, and many more. Of course, CSRD is not implemented yet. BRSR is already there in our system. Now, there are several modules available which help you in terms of strategizing an action. For an example, you can track your emission targets, see whether you are meeting those targets or not, and the tool also suggests what are the reduction requirements in order to meet the target that you've set. These can be all short-term goals, medium-term goals, as well as long-term goals that we have discussed just now. Our tool is built for scale, so it can be used by enterprise as well as consultants, and there are no limitations with respect to number of sites. As I've mentioned earlier, you can track emissions for n number of sites and entities. Finally, it's not just the tool, it's a collective expertise that we've got. We've got a team of ESG and carbon specialists, and we are available for all the supports For an example, identification of the right activities, which we did in this particular project, mapping it to the right scopes, and ultimately identifying the right emission factors and calculating them. So these are some of the things that we can do with respect to the carbon calculation. Some of the product snapshot for your reference, you can clearly see that we've got coverage of all scope emissions. You can see dashboards. There is a possibility of collecting data through surveys or external forms, and visualization of all of this data which is entered into the system. Now, ultimately, what Sustainium intends to provide is we want to be your end-to-end compliance partner, whether it is a requirement in the form of carbon accounting, ESG reporting, ESG strategy, or anything related to sustainability. So we'll take care of everything so that you don't have to. Now, reiterating the key takeaways with respect to today's discussion. Very important portion is the preparation of GHG inventory. So we should remember to identify all the activities which are there in the project boundary. We should map these activities with the right scope categories and prepare the GHG inventory utilizing local and international emission factors. Of course, local are the preferred emission factors to be utilized if they are available. Finally, using the GHG inventory to develop an emission baseline and use that baseline to set targets. Finally, develop a decarbonization roadmap based on the feasibility of various strategies that can be taken up, ultimately leading to net zero emissions for the project or the company. So that's all that we have today. Thank you. If there are any questions, I'll request the team to point it out. We can take all these questions.
The mic has been enabled for all of the attendees to ask questions if there are any.
This means everybody understood the GHG inventory and they'll be able to calculate it themselves.
So hi, thanks, Mr. Himanshu. This is Harman from Vardhaman Textiles Limited.
Hello, sir.
So it was quite a knowledgeable session, and I attended this for the first time. This link has been forwarded to me by my another counterpart.
Wonderful, sir.
So it was a very good explanation, and thanks for doing this. This is the requirement of everyone today.
Thank you, Mr. Arun. Thanks a lot. Any other comments, or somebody would want to mention something, or if there are any doubts, I can clear it off. If not, feel free to connect with us at hello@sustainium.io. You can also email me as well. You can find me on LinkedIn or connect with any of the team members, and we'll solve the problems for you. And if in case you need any demos, we are available for that as well. So with that, probably let's close this session. Thank you everyone for your attention. Have a very good evening.